Leave complexity behind. Have you ever stared at a massive, tangled block of code and felt completely lost in the details? Trust me, you are not alone. Today, we are demystifying one of the most strategic and powerful principles of object-oriented programming, or OOP. We're talking about abstraction. Our whole mission here is to show you exactly how to hide those unnecessary details so you can make your code simpler, way more scalable, and a lot easier to manage. Let's get into it.
Here is our roadmap for today. First, we'll talk about leaving complexity behind. Then, we'll answer the core question, what actually is abstraction? After that, we'll dive into the technical tools, like abstract classes and interfaces, followed by a great real-life example. And finally, we will clear up the biggest confusion out there, the difference between abstraction and encapsulation.
Part 1. Leave complexity behind.
I want to ask you a very direct question. When you get in your car to drive to work, do you need to know exactly how the engine works? Are you sitting at the steering wheel thinking about spark plug firing orders or engine combustion? Absolutely not. And that right there is the absolute core of the black box concept. Usability does not and should not require you to understand the internal mechanics.
Let's break that down. On one side, you have the user interface, the steering wheel, the pedals, the gear shift. It's clean, simple, and standard. On the exact opposite side, you have the hidden mechanics, fuel injection, spark plugs, combustion. As a driver, you only interact with that simple interface. All those chaotic, complex mechanics are intentionally hidden away from you. It's a brilliant design choice that lets anyone drive a car without needing a mechanical engineering degree.
Part 2. What is abstraction?
Bringing this back to programming, here is our formal definition. Abstraction is the process of hiding the unnecessary details of a complex system to show the user only the essential parts. And remember, in coding, the user is usually just another programmer using your code. Or, let's be honest, it's you 6 months from now. You shouldn't have to read thousands of lines of background code to understand how to use a class. You just need to know which method to call. This drops your cognitive load significantly.
As you can see, this is the golden rule of abstraction. It hides the how and shows the what. A well-abstracted class tells you what an object can do, like a calculate or save command, but keeps exactly how it does it a total secret. It simplifies interaction and draws a really safe, clear boundary between the public interface and that messy internal logic.
Part 3. Abstract classes and interfaces.
So, how do we actually build this in OOP? We have two primary tools. First, abstract classes. These provide partial implementation along with some rules. For example, in Python's ABC module, you can fill out some methods but leave others completely blank for subclasses to handle. Second, we have interfaces. These provide a very strict behavioral contract with zero implementation. Any class that uses an interface is forced to share the exact same method signatures, no exceptions.
I love this quote from our sources. An abstract class sets rules for subclasses. Let's visualize that. Imagine a parent abstract class called shape. This class forces every specific shape subclass, like a circle or a rectangle, to have an area method. Now, the shape class doesn't know how to calculate the area. A circle's formula is totally different from a rectangle's, but it sets the rule. If you want to be a shape in this system, you must know how to calculate your own area.
Part 4. Abstraction in real life. Let's look at a practical software architecture scenario. We have an e-commerce payment system with different payment types, credit card and crypto. Both of them share the exact same abstract method, pay. But the hidden complex details are completely different. A credit card requires connecting to a bank API and validating a CVV, while crypto requires blockchain verification. Thanks to abstraction, our central system doesn't need to know any of that. It just calls pay and moves on.
Let's step through the flow. The user clicks the checkout button. The system simply calls that abstract pay method. Then, the specific subclass steps in and executes its own hidden logic. Imagine for a second what your main code would look like without abstraction. You'd have a massive, unreadable nightmare of nested if-else blocks trying to check every single payment type. Abstraction literally saves us from that architectural disaster.
Part 5. Abstraction versus encapsulation.
So the crucial point here is understanding the difference between these two. Abstraction is all about hiding complexity. Its core question is, what is being done? Just like hiding the engine so you can drive the car. Encapsulation, on the other hand, is focused on protecting data. Its core question is, how is it secured? Think of a bank ATM. The cash inside is encapsulated. You can't just reach in and grab it. You can only access it through specific allowed methods like withdraw. So abstraction hides complexity to make things easy, while encapsulation hides internal state to keep things safe.
When you master abstraction, the benefits are huge. It massively reduces system complexity. It increases code readability because you aren't drowning in implementation details. It makes maintenance so much easier, allowing you to rewrite the internal mechanics of a class without breaking the rest of your app. This leads to seamless scalability when adding new features, and ultimately, it significantly lowers your risk of errors.
The ultimate flow of great software design looks just like this. You start with an abstract class to set the ground rules. This directly enables polymorphism, allowing that exact same pay method to behave dynamically differently for a credit card versus a crypto wallet. And the powerful combination of abstraction and polymorphism is what finally leads you to clean architecture. You end up with highly flexible modular systems that are incredibly resistant to breaking.
I want to leave you with a provocative question to think about for your own projects. Which complex details in your code are just waiting to be hidden? Take a hard look at your current architecture. Are you forcing other developers, or your future self, to understand the engine just to drive the car? Maybe it's time to step back, define a clean interface, and leverage the power of abstraction. Leave the complexity behind, and happy coding.